The Silence and the Storm. By mid-December 1944, the Ardennes forest had transformed into a deceptively tranquil landscape, a frozen wilderness that seemed far removed from the fires of total war. To the average American GI stationed along the 80-mile stretch of the Ghost Front, the European conflict felt like a spent fire flickering toward its inevitable conclusion. The forest was breathtakingly beautiful, cloaked in a heavy, crystalline rime ice that turned the ancient pines into jagged white cathedrals. In this sector, the war had entered a period of lethargy. Men traded Hershey bars for local schnapps, drafted hopeful letters to sweethearts in the States, and huddled in frozen foxholes, more concerned with frostbite than snipers. The prevailing Allied intelligence suggested that the German Wehrmacht was a broken force, a hollow shell capable only of a slow, grinding retreat toward the Rhine. Generals and privates alike believed the Krauts were out of fuel, out of men, and out of spirit. This complacency was a mask for a terrifying reality. While the Americans slept, the German war machine had moved 28 divisions into position under the cover of total radio silence and heavy fog. They were catastrophically wrong. At precisely 5:30 a.m. on December 16th, the tranquil silence of the Ardennes was shattered by the most concentrated German artillery barrage of the Western Front. Over 2,000 guns, ranging from 88mm flak guns to massive rail-mounted howitzers, opened fire simultaneously. It was a volcanic eruption of steel and fire that signaled the start of Operation Watch on the Rhine. This was Adolf Hitler's final desperate gamble, a lightning strike intended to split the Allied armies in two, seize the vital port of Antwerp, and force a negotiated peace that might yet save the Third Reich. For the German grenadiers waiting in their jump-off trenches, the plan was as bold as it was simple. Punch through the thin, inexperienced American line, seize vital road junctions, and drive to the sea before the Allied air power could reorganize in the clearing skies. As the German infantry began their advance through the freezing mist and waist-deep snow, they expected the standard patterns of war they had mastered over 5 years. Until this moment, artillery had been a game of hunker down. If you heard the whistle of an incoming shell, you dug deep, you stayed low, and you waited for the projectile to bury itself in the dirt before exploding. If it didn't strike your hole directly, the damp earth itself absorbed the blast and the lethal shrapnel. But on this morning, the fundamental physics of the battlefield had changed. The shells were screaming overhead, but they weren't hitting the ground. They were detonating with a terrifying metallic crack exactly 50 feet in the air. A lethal rain of white-hot steel fragments poured downward in a cone of destruction. This jagged hail followed the German soldiers into their deepest trenches, behind thick stone walls, and into the very foxholes designed to protect them from horizontal blasts. The safe zones of traditional infantry tactics had vanished in a heartbeat. The sky itself had been transformed into a sentient weapon, and for the first time in military history, there was nowhere left to hide.
The unauthorized savior, Colonel Axelson. While the German juggernaut, comprising nearly 250,000 men and 1,000 tanks, surged forward through the gaps in the fractured American line, the U.S. command structure was in a state of absolute paralyzed chaos. Communications were severed by saboteurs, and entire divisions were being bypassed or swallowed by the Black Panthers of the SS. Near the critical town of Monschau, at the northern hinge of the breakthrough, the 38th Cavalry Reconnaissance Squadron was staring into the abyss of total annihilation. They were a screen unit, lightly armored, mobile, and never intended to stand their ground against the weight of a full-scale panzer assault. Colonel Oscar Alfred Axelson, commander of the 406th Artillery Group, stood in his frigid command post watching a tactical map that was rapidly turning German red. He knew that if the Manschau sector collapsed, the Germans would have a clear run to the massive Allied fuel dumps at Liège. Axelson had a secret weapon in his magazines, a technological marvel known as the VT, or variable time, proximity fuse. This device used a miniature 5-tube radio transceiver to sense the ground and detonate the shell at the perfect height for maximum lethality. However, Axelson was strictly forbidden from using it. The Pentagon and the Supreme Allied Command viewed the VT fuse as a silver bullet, so strategically sensitive that its use over land was banned to prevent the Germans from recovering a dud. If the Nazis found an unexploded shell and reverse-engineered the miniature radar technology inside, the Allied bomber fleets currently leveling German cities would be decimated by smart anti-aircraft fire within months. To use it was to risk the entire strategic air campaign of World War II. As the morning progressed, Axelson listened to his radio operators, hearing the panicked screams of men being overrun by waves of German Volksgrenadiers. He was faced with a choice that should have ended his career and resulted in a court-martial: follow orders and watch his men be slaughtered, or break the rules and gamble the war's highest secret to save the line. He chose the latter. With a grim resolve, he bypassed his superiors and ordered his batteries to strip the security seals off the top-secret VT crates. "Load posit," he commanded, using the weapon's classified code name. The effect was instantaneous and horrific. The German 326th Volksgrenadier Division, caught in the open while moving to assault the American positions, was literally shredded where they stood. They had no cover against the airbursts. By the time High Command realized Axelson had ignored his standing orders, the German assault on the northern shoulder had been broken. Axelson had proven that a single battery equipped with proximity fuses was more effective than an entire battalion of conventional guns. His act of defiance held the Elsenborn Ridge, preventing the Germans from widening their breakthrough and protecting the vital supply lines that would eventually allow the Allies to counterattack and win the Battle of the Bulge.
The Section T secret, the miniaturization miracle. To truly grasp the sheer lethality of Colonel Axelson's decision at the Ardennes, one must look beyond the battlefield and into the classified laboratories of the American scientific establishment. While the Manhattan Project was famously racing to harness the power of the atom in the New Mexico desert, a parallel and equally vital effort known as Section T was quietly engineering the device that would decide the tactical outcome of the war's final year. Operating under the Office of Scientific Research and Development, OSRD, Section T was tasked with a goal that many contemporary engineers deemed a fantasy. Led by the brilliant and relentless Dr. Merle Tuve at the Johns Hopkins Applied Physics Laboratory, the development of the proximity fuse was a frantic, high-stakes sprint against the fundamental laws of physics. In the early 1940s, the world of high-end electronics was a fragile one. Electronics relied on vacuum tubes, delicate, thumb-sized glass cylinders that were so sensitive they could shatter if dropped on a carpeted floor. Tuve's team was tasked with a seemingly impossible engineering feat. They had to build a fully functioning 5-tube radio station that could survive being violently launched from the barrel of a 155mm long tom cannon. The physical stresses involved were staggering and nearly defied calculation. Upon the moment of firing, the internal components of the shell were subjected to a setback force of 20,000 times the force of gravity, 20,000 G. To put this in perspective, a human pilot typically blacks out at 9 G. Simultaneously, the rifling of the gun barrel forced the shell to begin spinning at a dizzying 30,000 revolutions per minute.
TÜV's team spent years in a brutal cycle of failure and innovation. They tested prototypes by dropping them from the tops of skyscrapers onto concrete and firing experimental shells into massive haystacks, only to dig them out and find the internal electronics reduced to glass dust. The ultimate breakthrough came in the form of a ruggedized tube, no larger than a pencil eraser, which was encased in a shock-absorbent block of solid wax or specialized resin. This innovation represented the true birth of hardened electronics, a precursor to the technology used in modern space exploration. Every proximity fuse was, in effect, a miniature, expendable robot. It housed a radio transmitter that emitted a continuous wave and a receiver that listened for the Doppler shift, the change in frequency as the wave bounced back from the ground or an approaching aircraft. When the return signal reached a specific frequency, indicating the shell was at the mathematically optimal height of 30 to 50 feet to spray a lethal cone of shrapnel, it triggered the firing circuit. This wasn't just a fuse, it was the world's first smart weapon.
The industrial home front, the arsenal of democracy. While the scientists in Maryland perfected the complex physics of the smart shell, the industrial heartland of Middle America was tasked with the equally daunting challenge of perfecting its mass production. The proximity fuse program was a logistical and industrial monster, eventually becoming the third highest priority of the entire U.S. war effort, trailing only the atomic bomb and the B-29 superfortress. It pulled over 100 different companies and a staggering 80,000 workers across the United States into a web of absolute secrecy. Electronic foundations. Industrial giants like RCA and Sylvania were tasked with manufacturing millions of the tiny, ruggedized vacuum tubes. They had to reinvent the assembly process to ensure that every single tube, smaller than a grape, could withstand the violent pressures of the front line. Mechanical precision. Eastman Kodak, leveraging its decades of expertise in high-end optics and camera shutters, was brought in to build the shell's intricate mechanical safety timers. These devices ensured the shell wouldn't arm itself until it was safely several hundred yards away from the American gunners. The assembly giant. The Crosley Corporation, a company famous for manufacturing household refrigerators and radios, retooled its entire assembly line in Cincinnati to fit the delicate electronic brains into the forged steel noses of heavy artillery shells. The level of precision required for this project was entirely unprecedented in the history of human manufacturing. In a standard munitions factory of the era, a 5% failure rate, where 5 out of 100 shells failed to explode, was considered an acceptable margin of error. However, for the proximity fuse, a 5% failure rate was catastrophic. If a fuse triggered too early, it resulted in a short round detonating directly over the heads of the American infantrymen the guns were supposed to be supporting. To prevent this, the women who comprised the vast majority of this specialized workforce, often referred to as the soldiers of production, worked under a grueling and obsessive regime of quality control. Every single fuse was tested and retested. The lives of thousands of men depended on the soldering of a wire no thicker than a human hair. By the height of the Battle of the Bulge in late 1944, American factories were achieving the impossible, churning out one proximity fuse every 2 seconds. The economic transformation was a miracle of capitalist scale and engineering efficiency. What had cost a prohibitive $732 per unit in 1942 was being produced for a mere $18 per unit by late 1944. This industrial deluge allowed the United States to fire over 22 million proximity fuses during the course of the war.
It turned the struggle against the Axis powers into a war of industrial mathematics, a relentless, high-tech rain of fire that the Nazis, for all their V-weapons and heavy tanks, could never hope to match.
The Ring of Fire, the Siege of Bastogne. The most legendary and brutal testing ground for this newfound industrial might was the besieged Belgian town of Bastogne. This vital road junction, where 7 major highways met in the heart of the Ardennes, became the focal point of the entire German offensive. Completely surrounded by the 5th Panzer Army and cut off from all ground-based logistics, the men of the 101st Airborne Division, the Screaming Eagles, were short on food, lacked winter boots, and were dangerously low on heavy ammunition. To the German High Command, the paratroopers were trapped in a cage, a mere nuisance waiting for the final, crushing blow from Hitler's armored elite. What the Germans failed to realize was that the American artillery, tucked inside that cage, was arguably the most lethal and technologically advanced in the world. The defense of the perimeter relied heavily on the 463rd Parachute Field Artillery and the 969th Field Artillery Battalion. The 969th was a distinguished African-American unit that faced the dual burden of the Nazi onslaught and the systemic racial segregation of the era. Despite these barriers, their expertise with heavy 155mm howitzers became the steel backbone of Bastogne's survival. For their unwavering courage and technical precision under fire, they would later earn the Distinguished Unit Citation, the first black unit to be so honored in World War II. Whenever German commanders attempted a human wave infantry assault or a massed panzer strike, the American gunners would call for airburst concentrations. In traditional artillery warfare, a gunner had to zero in through a tedious process of trial and error, painstakingly adjusting mechanical timers on every individual shell to match the target's distance. With proximity fuses, the shells became autonomous hunters. They found the optimal height to maximize their lethal radius on their own, even in the pitch black of a winter night, or through the thick, soupy fog that neutralized Allied air power. German prisoners captured at the perimeter were frequently found in a state of catatonic shock, their morale completely evaporated. They spoke in hushed, terrified tones about the lightning that follows you. The veterans of the Eastern Front, who had survived years of Russian bombardment, found this new American weapon incomprehensible. They had learned a bitter, inescapable lesson. If they stayed in the open, the airbursts shredded them. If they dove into a trench, the downward spraying shrapnel found them anyway. This impenetrable ring of fire provided the psychological and physical shield that allowed the battered bastards of Bastogne to hold their ground against overwhelming odds until help could arrive. Patton's Hammer, the Sauer River Massacre. General George S. Patton, the flamboyant and aggressive commander of the U.S. Third Army, was a man who instinctively appreciated the brute force of mathematics and industrial output. When he famously executed a 90-degree pivot of his entire army to relieve the pressure on the Ardennes, he did so with the full knowledge that he was bringing a technological nightmare to the German flank. He authorized the use of proximity fuses on a massive, unapologetic scale, famously remarking in a letter to the War Department that the device would require a whole new set of tactics for the world to understand, as it rendered traditional infantry defense obsolete. On Christmas Day, 1944, as the rest of the world looked for a moment of peace, a large German battalion was caught attempting a critical crossing of the Sauer River under the cover of a dense, freezing winter fog. The German commanders believed the weather was their ultimate shield. They assumed American observers couldn't see them through the whiteout and therefore couldn't call in accurate artillery fire. They were relying on the safety of invisibility. But Patton's gunners didn't need to see the soldiers. They knew the exact map coordinates of the riverbank, and they had the VT fuse. They executed what is known as a time on target, or TOT, barrage.
In a TOT mission, multiple batteries of different calibers and at different distances fire at staggered intervals so that every single shell from dozens of guns arrives at the target at the exact same second. Using proximity fuses, these shells screamed through the fog and detonated in a perfectly synchronized horizontal sheet of fire exactly 50 feet above the water. The result was a slaughter of industrial proportions. Patton later recorded in his personal diary that his burial details counted 702 German bodies on that single blood-soaked stretch of riverbank. There were no craters in the ground. The earth was untouched, but everything above it had been erased. The German army, once the pioneers of modern warfare, had no tactical response to a weapon that used radar to hunt them through the mist. The proximity fuse didn't just win a battle, it signaled the end of an era of warfare where an infantryman could find safety in the dirt.
The forest of splinters, turning nature against the defender. The Ardennes is defined by its geographical character, a labyrinth of deep valleys and dense ancient forests. For centuries, military doctrine held that deep woods were a sanctuary for the defender. Massive, centuries-old pines can stop small arms fire, and their complex root systems provided natural overhead protection for bunkers and foxholes. Before the winter of 1944, a soldier in the woods felt safe as long as he stayed low. The introduction of the proximity fuse, however, turned this ancient sanctuary into a hellish death trap. When a proximity-fused shell detected the treetops and detonated over the forest canopy, the resulting explosion was far more lethal than a blast on open ground. It created what soldiers came to call tree bursts. The downward-directed blast didn't just spray steel shrapnel, it shattered the frozen pines into millions of secondary projectiles. Thousands of jagged wooden splinters, some the size of toothpicks, others as long as javelins, were driven downward at supersonic speeds. This created a multi-threat environment that was impossible to survive without overhead concrete. German soldiers who had spent years mastering forest combat on the Eastern Front found that their hard-earned expertise was worse than useless. Digging in under a tree, once a basic rule of survival to hide from aerial observation, now made a squad a magnet for airburst sensors. Because the fragments and splinters struck from a nearly vertical angle, traditional foxholes became open graves. The psychological impact was as devastating as the physical one. Survivors often described a feeling of total exposure. The very forest they were defending began to feel like a sentient entity that was actively conspiring to annihilate the German army. It was no longer a battle of men against men, but of men against a sky that rained fire and a forest that turned into glass.
Institutional blindness, the German failure. The biting irony of the proximity fuse's success is that German scientists actually possessed the foundational technology first. As early as 1940, researchers at Rheinmetall and other German firms had developed working prototypes of radio-controlled and electrostatic fuses. Technologically, the Third Reich was initially ahead. However, the German High Command suffered from a fatal case of institutional blindness and bureaucratic stagnation. This failure can be traced directly to the top. Adolf Hitler, obsessed with immediate results, had issued a short-sighted decree. Any scientific project that could not guarantee a production-ready weapon within 6 months was to be canceled or stripped of its priority. He demanded victory now through massive tanks and rockets, and he had zero patience for the painstaking long-term R&D required for miniaturized electronic warfare. Consequently, the German proximity fuse program was mothballed, and its researchers were often drafted into the infantry just as the technology was nearing tactical maturity. Even more shocking was the German reaction to capturing the technology in the field. During the initial days of the Bulge, when the Wehrmacht overran several American supply depots, they captured over 20,000 intact proximity fuses. They held the Allies' greatest tactical secret in their hands. However, when German technical experts examined the devices, their own prejudices blinded them. They looked at the tiny glass vacuum tubes and declared, based on their own failed experiments, that such components were physically incapable of surviving the shock of a cannon blast. It is impossible, one report allegedly stated, that these delicate glass bulbs could withstand 20,000 gravities of acceleration. The German experts concluded the Americans were using a clever, non-functional decoy to distract German intelligence. they completely dismissed the possibility that the Allies had mastered ruggedized electronics. This institutional arrogance, the unwavering belief that if the master race cannot do it, the Americans certainly cannot, effectively ended their chance to counter the weapon. By the time they realized their mistake, the war was already lost, won by a tiny radio tube that the Nazis had dismissed as a toy.
The Luftwaffe's last stand, Operation Bodenplate. On the morning of New Year's Day, 1945, while many Allied soldiers were recovering from modest holiday celebrations, the German Luftwaffe launched its final, desperate air offensive of the war, Operation Bodenplate. In a massive, low-level surprise attack, nearly 900 German aircraft, the remnants of the once mighty Air Force, rose into the winter sky. The objective was to catch the Allied air forces on the ground and destroy their fighter wings at airfields across Belgium, Holland, and France. On paper, it was a masterpiece of tactical planning that should have crippled Allied air superiority for months. Instead, the German pilots flew into a vertical wall of proximity-fused anti-aircraft fire that defied anything they had encountered in the war's previous 5 years. This was not the erratic flak of 1942. The Allied anti-aircraft gunners were now operating the world's first fully integrated and automated kill chain. This system combined the SCR-584 radar, which could track high-speed targets with pinpoint accuracy, with the M9 gun director, an analog computer that calculated the necessary lead for the guns. The final lethal component of this chain was the 90mm shell equipped with a VT proximity fuse. For the first time in history, the human element of aiming and timing was largely removed from the equation. The radar tracked the plane, the computer moved the massive guns, and the proximity fuse ensured that the shell would detonate the moment it was within the lethal kill radius of the aircraft's engine or cockpit. The German pilots, many of whom were young and inexperienced, were decimated by shells that didn't even require a direct hit to be fatal. A near miss was now as good as a bullseye. Of the 277 German aircraft lost during the operation, the vast majority were not shot down in dogfights, but were victims of this automated ground defense. The Luftwaffe, having lost its remaining veteran pilots in a single morning, never recovered from the carnage of Bodenplate. The arsenal of democracy had successfully automated the defense of the skies, proving that technology could outpace even the most daring human bravery.
The legacy of smart death, from the Ardennes to the stars. The Battle of the Bulge finally sputtered out in the freezing mud of late January 1945. The mathematics of death had exacted a heavy and heartbreaking toll. 19,000 Americans and over 100,000 Germans lay dead in the snow. When the dust settled, the impact of the proximity fuse was undeniable. Field Marshal Gerhard von Rundstedt, the commander of German forces in the West, later admitted during Allied interrogation that the proximity fuse was one of the 3 primary reasons the German offensive had failed. He stated grimly, "The American artillery was the terror of our soldiers, especially the shells that had eyes." However, the legacy of this weapon extends far beyond the blood-soaked hills of the Ardennes. The technical hurdles overcome by Dr. Merle Tuve and Section T scientists acted as a catalyst for the electronics revolution. The miniaturized, ruggedized vacuum tubes developed for the posit shell were the direct conceptual ancestors of the modern transistor. The project proved that electronics could be made small, durable, and reliable enough to survive extreme environments, a realization that would eventually make the pocket radio, the personal computer, and the smartphone possible. Furthermore, the organizational methods used to coordinate hundreds of private suppliers like RCA, Kodak, and Crosley under a veil of total secrecy became the foundational blueprint for the modern military-industrial complex. It established the model for how a government could harness private industry for massive high-tech R&D projects, a model later used for the Apollo moon landings and the development of the Internet. Perhaps most importantly, the proximity fuse fundamentally altered the morality and nature of modern warfare. It was the world's first true smart weapon. Every GPS-guided bomb, every heat-seeking missile, and every drone-mounted projectile used in modern conflict is a direct descendant of the shell fired by Colonel Axelson at Monschau. The proximity fuse proved a cold, hard truth of the 20th century. In the age of high technology, the side with the most productive factories and the most innovative laboratories is the side that ultimately writes the history books. The Ghost Front was not just won by the bravery of GIs and foxholes, but by the silent, whirring vacuum tubes that brought the future of warfare into the present.